create appropriate spaces for the development of productive activities has been highlighted in order to obtain the best performance in operations. However, at this time, the first plant layout techniques characterized by contact physical management of all the elements necessary for the execution of production processes. Over time, the complexity of production systems grew, and likewise the problems related to plant layout were emerging. With the emergence of all different problems in finding the most economical and also flexible arrangement of work areas, equipment, materials, and personnel, it is possible to observe how the plane and plant layout take on new meaning, where, besides being a science, become an art that requires skills and experience. The areas according to which departments are ordered are defined by the general pattern of the workflow. Exist those different basic type of distribution, among which is the distribution of fixed position. The fixed position distribution, project or product remains in place either by volume or weight, and workers and equipment to manufacture come to that workspace or product. Techniques for studying the distribution problems of fixed position are not in development and are complicated because of two factors. First, space is limited almost everywhere. Second, because at different stages of the construction process, different materials are needed, different items become important as the project progresses. Third, the volume of materials needed is dynamic. The advantages of this type of distribution may be few distances traveled by materials, multitask teamwork, continuity of operations, and high level of flexibility. Among the disadvantages are more movement of personnel and equipment, trade staff required, larger facilities, longer processing time. Scheduling of production requires much coordination and control. Fixed position distribution is characterized by following. Work process. All workstations are installed on an interbasis by the principal component or assembly that is manufactured or assembled. Material work in progress. The material is taken to the place of manufacture or assembly. Versatility. They have wide versatility, adapt easily to any variation. Continuity of operations. Neither the waiting time nor workloads are stable. Even the weather conditions may impact on the operation. Incentive. Depends on the individual worker's job. Qualification of the workforce. The equipment are usually very conventional. Even if one particular machine is used, it is not very specialized, so it does not have to be highly qualified. By developing a fixed position distribution, you can view the product as the hub of a wheel, with the materials and equipment arranged in a consistent way around the point of production according to the use and difficulty of moving. In a fixed position distribution, it is common that a high degree of scheduling tasks is presented, and to the extent that these precedents determine the product steps, a fixed position distribution can be developed, arranging the materials according to their technological priority. As regards the techniques of quantitative distribution, there is little literature on fixed position formats, even when they have been used for thousands of years. In certain situations, however, it might be possible to specify objective criteria and develop a fixed position distribution through quantitative means.
Imagine an airplane with a seating capacity for 600 people. Imagine an airplane with showers, shops, and bars. Imagine a plane that could change air travel forever. Right now, that dream is coming true. A visionary bit of big money, technology, large machines, and gigantic buildings. The creation of layers, more powerful and more luxurious airline in history, the Airbus A380, giant of skies. The Airbus A380 is a four-engine plane with two decks manufactured by European company Airbus, a subsidiary of AIDEs, with up to 808 seats. Is the aircraft's world's largest passenger, beating Boeing 747. The main structural sections and most of the parts of the A380 are built in France, Germany, Spain, and the UK. Because of its large size, the parts manufactured in different countries are brought to the assembly plant Jean-Luc Lagarche in Toulouse, France. For the transport of the various components is mostly used on land and sea transport. To sometimes transport through A300 to 600 ST Beluga. Planes specially designed for the transport of bulky goods. The components of Airbus A380 are provided by suppliers worldwide, among which are Rolls-Royce, Safran, United Technologies, General Electric, and Goodrich. For the movement of the components are available a large fleet of trucks and boats, plus specialized facilities and roads modified to accommodate large convoys. The front and rear fuselage sections are manufactured in Airbus Industries located in Hamburg, northern Germany, where they are transported by sea to UK. The wings are manufactured in Great Britain, particularly in Bristol and Brooktown, from where they are transported to France. In Saint-Nazaire, western France, get the parts manufactured both in Bristol and Hamburg. The tail and belly of the aircraft are assembled in Getafe, Spain, for where they are transported by road. In the case of the heavy pieces, occasionally also use the Airbus Beluga A380 to 600 ST for transportation to France. Finally, all parts manufactured and assembled in different countries are carried by road or sea to the assembly of Toulouse. After assembly, the aircraft is flown to Hamburg, where it is furnished and painted. 3,600 liters of paint are needed to cover its 3,100 square meters. This complex manufacturing process costs only 4 Airbus A380 can be built each month.
The wings are manufactured in Brown, UK. The tail is stabilized in Puerto Real, Spain, part of the fuselage in Hamburg, Germany. The cockpit and the central part of the fuselage in Saint-Nazaire, France, etc. All these components are transported to Toronto. Final assembly plant by sea, land, or air with a very complex logistic which will be described later. The choice of material is a key aspect when designing an airplane. The materials used in the construction of the Airbus A380 are particularly innovative. About 25% of the aircraft is built in composite materials, 22% carbon fiber, 6 times stronger and 60% lighter than steel, and 2% of glaze. The glaze is constituted by alternating layers of aluminum foil and fiberglass. This is the first time it is used in the civil aircraft. It is not only lighter than aluminum but also behaves better in a fire and has more resistance to fatigue. The metal used is mostly aluminum. Metal such as titanium, fast subjected to high loads, and steel are also used. The structure on the top floor of the A380 is made of composite materials, and the lower floor made of a alloy of aluminum and lithium. Previous fuselage. On the plane located in Saint-Nazaire, the front of the fuselage is assembled. It is divided into 3 main parts. Section 11, which the mount and is manufactured in York. Section 12, also manufactured in York. Section 30, which a tube fuselage about 10 meters, manufactured in Hamburg and comes fully equipped. Systems in the cockpit and some equipment are installed and allow the section as finished as possible to minimize wear at the plane in Toulouse. Central fuselage is also assembled at the plant located in Saint-Nazaire from elements from other plants. It has the following main sources: central box manufactured in Europe, Housing made under carriage made in Lao. Center fairing manufactured in Puerto Real. Center fuselage tube manufactured in Saint Lucia. All systems and equipment possible at this stage of manufacture are installed. It is tested and prepared for transportation to Tokyo. Rear fuselage. It is assembled at the plant in Hamburg. It consists of the following parts. Section 1841 is manufactured in Hamburg. Section 1843 is also manufactured in Hamburg from a section fuselage mold heads separating the area pressurized and non-pressurized aircraft. Section 19 is manufactured in Getafe. Is made of composite material. As in the previous case, is equipped as much as possible to minimize the wear in fuselage and gain time in the final assembly.
Wings. They are manufactured at the plant in Brooklyn. They have the distinction of having a significant size and have few tolerances in manufacturing, as it is an airfoil. The fact that also is the case of a fuel tank makes its manufacture complex and requires great precision in the joints to prevent leakage. Horizontal stabilizer. The plant located in Puerto Real is responsible for manufacturing the horizontal stabilizer. As the wings, this has very little manufacture tolerance to also be an airfoil. Likewise, it is a fuel tank, which is required so that connections are made very accurate and make high-quality sealing works. It has a fixed and a movable part, the elevators. Vertical stabilizer. The vertical stabilizer is manufactured at the planting state. Like the horizontal stabilizer, has a fixed part and a movable part, rudders. In manufacturing, must meet the requirements of airfoil. Other components sent directly to the FAL. In addition to the parts listed above are other smaller components that are sent directly to the FAL. This is the case of engines, hood and reverses, landing gear, more rare section of the plane, APU, auxiliary power unit, pylons, etc. Transporting the components. The transportation of components from one plane to another and from these to the final assembly plant in Toulouse has required a thorough study to minimize cost, time, and prevent damage which may occur during it. The Airbus A380 has the added problem of the large size of its components, so it had to find alternative transportation suited to this aircraft. Has been necessary to create a complex network. The transport is by sea, land and air, for which boats, special manufactured aircraft to transport parts, beluga, and special vehicles for transport by land are used. Some boats have been suitable winded for the passage of these convoys, and ports have been built gaining groundwater, as in the case of the port of Hamburg plant.
Manufacturing parts of the Airbus A380 were described previously along the video, among which are fuselage, wings, and other components. Process. The production process of the Airbus A380 is categorized as an ensemble of the main parts and which, as mentioned above, have already been described. These parts are made by fairly armed processes involving human talent, highly trained and efficient. Plant. Given the process described for manufacturing the Airbus A380, even then there is a final assembly plant located in Toulouse in different cities, different plants, where simultaneous processes that contribute to the manufacturing of Airbus A380 are located, planning and control, procedures and information management uses to operate the system. Conclusion of video described be seen throughout the video the description of the manufacturing process of the Airbus A380. alarm acquisition and analysis product mainly, and identifying the type of distribution system used in this development fixed position. From the above, identifying effect alerted a more specific a complex production process Airbus A380 analysis and altered the diverses of its preparation from people to their complex planning.